Okay, this is Algebra 1, Lesson 7.4. We're going to start with our warm-up, so make sure you guys pause and try the warm-up. I apologize if my dogs start barking. They're sitting right here, and I know they like to be obnoxious, so we'll see what happens. Okay, so the first one, x squared taken to the third power. Now we talked about if a exponent is raised to a power, we need to multiply those exponents, so this is going to be x to the sixth. If we have a negative exponent, we need to make it positive, and the way we do that is by moving it to the opposite location, and in this case it was in the numerator, so we're going to move it to the denominator. And you can either leave it as 2 to the third, or 2 times 2 times 2 is 8, so you could rewrite it like that as well. Okay, for this next one, we need to move the x to the -1 to the denominator. The 3 to the 2 stays in the numerator, and all we do is we move the x to the first power down. If you want to write x to the first power, you can, but you don't have to since it's just the first power. Okay, so I would suggest distributing this power first to these powers. So we get v to the +6, because a negative times a negative is a positive, and w to the -9th. Now that changed which one we need to move down. We actually need to move the w down, so we're going to have v to the 6th staying in the top and w to the 9th in the bottom. Okay, so our next one, we are going to move the 3 to the -2 down and do this. We haven't talked about this, but we're going to learn today. If we have something with the same base, and then, actually, I'm going to teach this a different way. I lied. We talked about this. If it's the same base, you just add the exponent. So 8 minus 2 is 3 to the 6th. Sorry about that. We'll talk about this other way today. Okay, for this next one, we can distribute that y to the third and z to the third. We can write it this way. That third power can be distributed to both. Okay, so this next one says to write it in scientific notation. It looks like we have them in scientific notation, but they're actually not in the correct scientific notation format, because if you notice, the numbers out in front are not greater at 1 or greater but less than 10. So 30 is bigger than 10. So we need to take the decimal place and move it over. So that becomes 3.0. Now, because we moved it back one place, this is going to become a -2. Because from here, originally it wanted us to move it 3 places this way. Well, we've already moved it one of those places, so that's why it's going down. For this next one, we're going to pick up that decimal place and move it between the 1 and the 6. So now we have a number between 1 and 10. Since I moved it this way, I'm taking away one of these. Again, the original number said to move it 7 places. I've moved it one of those already, so now we only have to move it 6 places to the right. So today we're going to look at using division properties of exponents to evaluate powers. A quotient of powers with the same base, okay, so it has to have the same base, can be found by writing the powers in a factored form and dividing out the common factors. So for example, 3 to the 5th over 3 to the 3rd, if we wanted to in the long way, we could write out 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3. And anything that is the same, however many we have, we can cancel. And we're only left with 3 to the 3 times 3 on top, which is 3 squared. So notice the relationship. All you're doing is you are subtracting exponents. So for our quotient rule, you are subtracting exponents. So you're subtracting the denominator. So the denominator from the numerator. Or if you don't want to memorize that, all you have to remember is that numerator. Let me write this first. All you have to remember is whichever one had the bigger number, that's where it's going to go. So if I had 3 to the 3rd on top over 3 to the 5th, the difference, yes, is still 2, but it goes with the one that has more of it. So this had more because it started with 5. So that's why it would be down. So you don't always have to memorize the numerator from the denominator thing. Just know it's wherever there's more. So here's it written out. The quotient of two non-zero powers equals the base raised to the difference, or subtracting the exponents. So 7 minus 4 in this case. we would get 6 to the third. So let's try this. Okay, so in A, we've got the same base, a base of 2. We've got 7 on top and 2 on the bottom, so the difference of those is 5, and since there were more on top, it's going to be 2 to the 5th. Okay, for B, we've got 4 and 3. Our base is the same, so we subtract 3 from 4, and we're just left with x to the first or just x. Before we solve this one, we need to distribute, so I'm going to write this out, 4e to the third. We need to distribute this first, so d squared e squared. Now we're going to take the difference. D to the fourth minus d to the second is d to the second. E to the third minus e to the second is just an e, 1e. Okay, so here's where I was talking about if there's more in the denominator, that's where you're going to write the number. So looking at these 3's, they have the same base. And remember, if it's not written, we assume there's a 1 there. And since there's more 2's, 2 is bigger than 1, our 3 is going to go in the denominator. And how many? What's the difference? Well, 2 minus 1 is 1. And you can write the 1 if you want, but you don't have to. Okay, next one. So we've got a base of 4. So there is more of the 4's in the bottom. There's 1 more of them. So it's going to stay in the bottom. And with the 5's, there are more 5's in the top. We've got 2 more 5's than in the top than we do the bottom. So our answer is 5 squared over 3 times 4. And if you want to simplify this out, you should know that 5 squared is 25 and 3 times 4 is 12. So that is your answer. Okay, let's try this next one. Okay, again, you want to take care of any outside powers first. So m to the 5th, that should be an n to the 4th, over, that becomes m to the 10th times n. Now, we have more m's in the bottom. We actually have 5 more of them. The difference of 5 and 10 is 5. And we have more n's in the top. How many more? Well, there's 1 in the bottom, 4 on top, so that's a difference of 3. So our answer is n to the 3rd over m to the 5th. Okay, next one, we've got a difference of 1, but that there's more 3's in top, so that's going to stay on top, 1, 3. We've got more 2's on top. How many more? 2 more, so we're going to keep 2 2's. And then how many more 4's do we have in the bottom? Well, we have 3 more, so 4 to the 3rd. For now, I'm okay with you guys leaving it like this. If you can do some of these in your head, go ahead and actually multiply them out. You know, 2 squared is 4, so that would become 12 on the top. And then 4 times 4 is 16, times another 4 is 64. And that can actually simplify further. Let's see what goes into this. Well, half of this is 32, half of that is 6, and we can simplify it even more. We can simplify it down to 3 over 16. But if you left it like this for now, I'm okay with that. All right, since you guys don't have calculators. Okay, so now we're going to talk about dividing numbers with scientific notation. So if we have 3 times 10 to the 10th divided by 6 times 10 to the 6th, okay? So that's the division bar. I'm writing it as a fraction. You're going to actually divide this out, okay? 3 divided by 6 is a half, or 0.5. In this case, with scientific notation, we do need to use decimals, so don't leave it as a fraction. And then the difference of these 10s, 10 minus 6 is 4. Okay, we're not done though. Remember, this number out in front has to be between 1 and 10, or 1 or greater than 1 or equal to 1, but less than 10. So we need to move that decimal place over. So it becomes 5 times 10 to the 3rd. Okay, since we already took away one of those 4 places to the right, it now becomes 10 to the 3rd. So again, we divide out the numbers out here, and then because these are the same base over here, we subtract the exponents. You can split up a quotient of products into products of quotients. For example, if I have a number times a number divided by another number times another number, I can split them up into those first numbers divided out times those second numbers. So here's an example of that. that can help a lot in a problem. That's kind of what we just did with the scientific notation. Where was that? I could have written this, if it made more sense to you, as 3 divided by 6 times 10 to the 10th over 10 to the 6th. So that's all they're saying. You can divide it up if that makes it easier to look at. Okay, so the Colorado Department of Education spent 4.408 times 10 to the 9th dollars in 2004 to 2005. There were 7.6 times 10 to the 5th students in the whole school. What was the average spending per student? So this is the total amount of money they spent. This is the total amount of students. So we need to take the money divided by how many students there were. And again, we can split this up. And if on a quiz or something, I would give you easier numbers that you could do in your head. Okay, so 4.408 times divided by 7.6 is equal to 0.58. And then times 10, we need to subtract these to the 4th. We're not done though, we need to move that over. So it becomes 5.8 times 10 to the 3rd because we took away one of these 4 places to the right. Or if you want to rewrite this, and we could move this over 3 places and it becomes $5,800. A power of a quotient can be found by first writing the numerator and the denominator as powers. So again, this is kind of what I did in the warm-up. This power has to get distributed to both the numerator and the denominator. So we would simplify it by writing it in the top and the bottom for our final answer. So a quotient raised to a power equals the quotient of the base raised to that power. So any value 1/2 to the 7th, that would equal 1 to the 7th over 2 to the 7th. Okay, that's the same thing. And this is the simplified version, not this. So to simplify this, we're going to write 4 to the 2nd over 7 to the 2nd. 4 squared is 16, and 7 squared is 49. And you are done. I would expect you to be able to do something like that without a calculator, okay? You don't need a calculator to do 4 squared and 7 squared. Okay, so first we're going to take this to every little thing. So we're taking 3 to the 4th power, and you don't have to do this in that one in your head. D to the 2nd, when we multiply that by 4, that becomes D to the 8th. E actually has a 1 here, so we're going to multiply that by 4, so it becomes e to the 4th, and then f to the 4th. So this is our answer. You don't actually have to carry out that 3 to the 4th power. Okay, don't distribute this first here. Work your way from this first, so kind of our order of operations. So I'm going to rewrite this as 2x to the 3rd, all raised to the 2nd. Now this is going to go to everything inside, so it's going to be x to the 3rd, y to the 3rd. Now we're going to square every little thing inside, okay? So 2 squared becomes 4. X to the 3rd squared becomes x to the 6th because we multiply. X to the 3rd times x squared becomes x to the 6th, and then y to the 3rd squared becomes y to the 6th. Now if you notice, I can simplify this because they are the same base. Since they have the same power, they just cancel, and we're left with 4 over y to the 6th. So rewind that if I went too quickly. Again, it's kind of an order of operations thing. Remember that x to a negative power, if we rewrite it as 1 over that power, it makes it positive. So for example, if I have a over b, a number over another number, to a negative power, this is kind of walking you through how, if you rewrote it and rearranged everything, basically, if you have a fraction raised to a negative power, to make that power positive, all you have to do is flip the numerator and the denominator, okay? And right here is the proof behind why you can do that. You can walk yourself through that. It makes sense. It might actually help make more sense to you why that is. But if it is raised to a negative power and I have a fraction inside, I can flip the numerator and the denominator, and that will make that power positive. So any a quotient, they're calling it a quotient or a fraction, raised to a negative power equals the reciprocal raised to the positive form of that power. So here we go. I have a quotient inside raised to the negative third power. So I'm going to flip the top at the bottom and then now make the power positive. Okay. Now we should rewrite this as 4 to the third over 3 to the third. And that is your answer. Okay, for this next one, again, I have a quotient to a negative power. So all I'm going to do is flip everything in the numerator and denominator. So my y to the third comes up, my 2x squared goes down, and then I have it to a positive 2 now. Now we can distribute that to everything inside. So we'll have y to the 6th on top, 2 squared. Remember, you have to carry it through your coefficients as well. So the 2 times 2 becomes 4, and then x squared squared becomes x to the 4th. And that is our final answer. Again, if I'm going too quickly, please go back and look at these examples. Okay, so first on this problem, we've got 2 negative powers, and we've got quotients inside. So to make this one positive, I'm going to rewrite it as 3 over 2 to the positive 2, and I'm going to flip these. So I'll have 2n on top over 6m to the positive third now. Now I need to distribute this, so I get 3 squared over 2 squared times, this has to go to everything on the inside, 2 times 2 times 2, 2 cubed is 8, n to the third. You don't have to do the 6 cubed, I'm fine with that right now, times m to the third. So we've kind of got, actually, I'm going to go back to what it was. Where's my eraser? I'm going to tell you why. Don't actually carry that out. Here's why. If we write 2 cubed, okay, now we can multiply straight across. So we're going to have 3 squared, 2 to the third, n to the third, over 2 squared, 6 to the third, m to the third. Okay, right here, these have the same base, so we can subtract their powers. So that will become 3 squared times 2 times n squared, or cubed. You don't need to put these little dots here. And we canceled this out, so we have 6 to the third, m to the third. Again, you don't have a calculator, but if you were to do this out, this would actually, you're going to get some numbers out here that will cancel, but for now I'm fine. I'm more concerned with the variables and making sure you understand that. So just be aware. Remember, when all the factors of a numerator or denominator divide out, replace them with a 1. So this, because it canceled out, it became just a 1, and 1 times 6 is just, or 6 to the third is just 6 to the third. So if something cancels out, it becomes a 1. It doesn't become 0. Okay, so lesson quiz. This lesson is pretty heavy, so go ahead and pause this and try these, and then make sure you're on the right track. Okay? Okay, sorry about that. So we're going to subtract our exponents. So 8 minus 3 is 5, so we have 4 to the 5th. Here I'm going to distribute first, so I get 8 to the 5th, y to the 2nd, over x to the 3rd, y to the 3rd. Now I can subtract these, so I get x to the 2nd on top and y on the bottom, because there's only the difference of 1 and there's more on the bottom. Okay, this has to go to every little thing. So we've got 2 cubed, x cubed, y to the 6th, x to the 9th, y to the 3rd. Now, I can combine these, I can combine these. So my answer is 2 to the 3rd. My x's on top go away. I've got 3 y's left on the top, and I've got 6 x's left on the bottom. Okay. Remember, if it's a negative exponent, you flip the numerator and the denominator. So I'm going to make that n to the 3rd over 4m to the positive 2. Now this gets distributed to everything inside. So I have n to the 6th, 4 to the 2nd. Be careful you guys aren't taking 4 times 2. It's 4 squared, 4 times 4, and m squared. If you want, you can rewrite this as n to the 6 over 16m squared, because 4 times 4 is 16. That one you should know. Okay, first and foremost, I'm going to flip this. So I have 3 over c squared times 2c over 9d squared to the third. Then I'm going to distribute the power to everything inside. So 3 squared over c squared times 2 to the third times c to the third over 9 to the third times d squared. Okay, so now if I write that out, I have 3 squared, 2 cubed, c to the third. I'm going to put the 9 out in front, 9 to the third. We can rewrite that in any order since this is a multiplication problem. And d to the second. Now, these right here, I can cancel these with most of these except one of them. So I'm left with 3 squared, 2 cubed, 1c, and 9 cubed times d to the second. Now, I know that you don't have a calculator, so you can't do all of this, but these numbers, yes, they will cancel out, and you'll actually get 8c over 81d to this, did I miss something? This should be to the 6th. Look at that. This 3 needs to multiply by that 2. My bad. To the 6th. So this is actually your answer, but if you left it like this, I would be okay with that as well. Okay, so ask lots of questions in class about this lesson, and that should be all.